All of you are welcome to the expert presentation in the chemistry and the P block elements are to be discussed here. What are the P block elements as per periodic table, their electronic configuration that will be also discussed, and their compounds are whatever the carbon compounds, the nitrogen compound, sulfur compounds, all those are to be discussed in this presentation very well that periodic table and in which p block elements are such elements where the electron is filled in p atomic orbitals according to the periodic table and the atomic structure as well as the quantum numbers, their general electronic configuration is whatever in their respective periods ns2 and p1 to 6. Here the p orbitals, p atomic orbitals are of 3n number: px atomic orbital, py atomic orbital, and pz atomic orbital. So whereas the subcell itself is the p subcell. So according to Hobsbawm principle, the electrons are filled as per the energy relationship. So here the first period which have only the two elements. So there is no chances of any of the 1p subcell or 1p atomic orbital as per the quantum numbers of electrons. So therefore, in case of the period 2, where the atomic number starts from the 3, so 3 to 10 atomic number, and here the that 3 and 4 are the alkali and alkaline metals. So whatever you start from the atomic number 5, that is the boron having the electronic configuration 1s2, 2s2, 2p1, and later on the continue the elements up to 10. So these are the p block elements, and in which the group also, that is whatever the third A, fourth A, fifth A group, sixth A, seventh A, and last one is the zero group. Zero group that is the inert gas. So that is also in the part of the p block elements. So this is all about the period number 2, and in which the various so whatever I have discussed here, the p block elements, their general configuration itself is ns2, then np 1 to 6. So here the electrons are filled according to Hobsbawm. The p block elements are there. So therefore we can say, uh, for example, in case of the period number 2, all of you are well known about that. Whatever the s block elements having the filling of electron in the s atomic orbital, whereas the p block, that is the specific area, and p block are related with the electrons are filled in their respective p atomic orbitals. So here the mentioning of the p blocks are, and I have already discussed that these are also, so 3a, 4a, And here we can also give the further classification as per whatever that new modern periodic table, where the groups are arranged from top to bottom. And here 13, 14, 15, 16, 17, 18 groups are there. So here the modern periodic table, earlier that was configured into in the third day, fourth day, fifth day. So now 2p, that is of second periodic periods, the 3p that relates with the third period, fourth period, and like that. So here the question is there, how the electrons are filled in up to the 6p atomic. Here we start from the 2p blocks, where the shell number is the 2, and shell number, all of you are well known about that. That is also principal quantum number. So we start from the boron, carbon, nitrogen, oxygen, fluorine, and neon. Here, the description in the periodic table is as per uh, the modern one. So 18, 1 to 18. That is the periodic table. Out of these 18, 1, 2, and then the gap, and P block start from the 13, 14, 15, 16, 17, and 18 also. Here we can also mention whatever the helium and hydrogen. Those helium does not have any of the p atomic orbital, which is to fill. So here this whole block 13, 14, 15, 16, 17, and 18 start from the boron. So boron, then carbon, then nitrogen, oxygen, fluorine, and neon. The third word 3p will be aluminium, silicon, phosphorus, sulfur, chlorine, argon, gallium, germanium, arsenic, selenium, brominium, and krypton. Then we have the indium, tin, antimony, tellurium, iodine, and xenon. So this is all over the periodic table, in which the concern uh, are the whatever can say that the boron. So in here the that is boron, the electron come in p1, and carbon p2, nitrogen p3, oxygen p4, nitrogen, fluorine p5, and neon p6. So 2p1, 2p2, p3, 2p4, 2p5, and 2p6. So overall neon we got, and we are well known about that. The group number 18. Group number 18 is inert gas. So because of the atomic complete their respective shell, the electrons. Electrons are filled in complete filled uh, atomic orbital in case of the p. So now we can say the group 13, group 14, group 15, and group 16, group 17. 17 itself start from the fluorine, and group 18. So group number 18 is the inert one. 17, this one itself is uh, uh, the halides only. So here boron, carbon, and whatever the nitrogen, oxygen, and fluorine. So Here we can say that particular respective groups. Germanium, the group number 40, whatever there is the role of the advanced technology and that particular the concern of the conductors, semiconductors, whatever the memory material, silicon itself, germanium. Then lots of work have been. However, indium and that is also most important concern. So let's the P block elements are most of the importance in the different technologies. Why? One more thing is there when we have the group number 13 and only one electron is filled in p subcell, that is of the px1. So px1, whatever, if suppose boron compounds are there and boron fluoride is there, so here one most the fundamental octet rule. So that is not followed by the boron compounds. So those are the compounds of boron are electron deficient. So one more thing is there, the carbon itself, carbon, the family, the 14 itself having the valency is the 4. So from boron, 3, 4, 5, 6, 7, whatever then valency we can say for the nitrogen, this is the 3 trivalent mostly, and in case of the oxygen, the divalent, and in case of fluorine. So whatever the octet rule follow, so how many electrons remain for that. So we can say the boron family and then carbon family and nitrogen family and then oxygen family. Whatever that is the also the name of the family. So now we can also see one more thing is the shell model, so where the valence shell. So here also one of the uh, 2p and 3p. In case of the 2p and 3p, the different electronic configurations are mentioned. One more thing is there, how valence shell of first 18 elements. Out of those 18 elements, we have to regarding about the 13, 14, 15, 16, 17, and 18 group. So here that is the clearly indicates that the shell and shell here we have the boron that clearly indicates the 3 electrons, and in case of the carbon the 4 electrons. So four the outer shell electrons are there. So we can say uh, in case of the nitrogen, 4 electrons, and then carbon 4 electron, and nitrogen having the 5 electron. Oxygen the 6, and then fluorine having. So those are the shell, whatever the outer shell, and that is in which the different atomic orbitals are there. So here the shell model clearly indicates that what are the requirement to complete the octet. For example, in case of the boron, is boron containing boron needs the 5, then carbon needs the 4, nitrogen needs the 3, respectively. Oxygen needs 2. So I have earlier discussed about the monovalent, bivalent, trivalent, and tetravalent. Boron family are the trivalent. Then tetravalent, then we have the pen, trivalent, divalent, and monovalent. Whatever the neon itself is the zero valent. So here, uh, outer shell, the respective electrons are arranged, and that is the fundamental behind that different. technologies are based on the electrons, and those are mostly of the outer shell electron. How many number of electrons are present in outer shell? So that is the most important concern. The carbon CH4 is formed. Why CH4 is formed? In case of the boron, the diboron B2S6, so BH3. So why that particular diboron is formed? And in case of the fluorine, why it take one electron? That is because of the outer shell electrons. So how many number of outer shell electron present? That is the responsible for the uh, characteristics of that particular element. So p block elements here variety, whatever the mono, the di, the trivalent, as well as the tetravalent. The carbon family compounds are also most important relevant in those particular case because carbon relates also with the organic compounds, where in case of the organic compound hydrocarbons and their derivatives, that is the organic compound, so that is from the p block element. And all of you are well known about that number of organic compounds, even 7 million number of organic compound present at this point. So this is the whole of periodic table in which the one element carbon, that is relates with the organic compound. So organic compounds, how many number of organic compounds? 7 million. 70 lakh organic compounds are existed at this moment. Whatever there, those related on this planet. So hydrocarbon and their derivatives, that is the concern of the whatever the organic. This is the part of the p block element. Electronic configuration of carbon, that states here that clearly indicates in the picture that 4 electrons there, and for completion of the octet of a carbon, this needs another 4 electrons. So therefore, this one is the tetravalent. Whatever the oxidation state can also be varied from place to place. So now we have to then silicon, most important in the memory material. Silicon chips for the different uh, gadgets that relates with the computational programs, computational computer chips, whatever the mobile chips, various electronic devices. Those certainly needs the silicon chips. So that is silicon is also. So we have to see the carbon and silicon. Carbon having the 70 lakh compounds and silicon the most important in the memory material. So memory silicon chips is the concern of the computational programs, and those are very small, very thin chips, memory chips are there, and those are of the silicon. So great opportunities, great values, and this P block elements, especially whatever the 2p and 3p p block elements relation. The 2p is in the second shell, the 3p in the uh, third shell. So here some of the whatever the some queries and those related with this whatever how the boron form the compounds, how carbon form the compound. So we have in time whatever they are elements and what are the questions arise that how nitrogen oxide is formed, how oxygen is related with the acidity, and how fluorine itself have the electronegative elements, and it can form fluorine, fluoride ion. chlorine. Why chlorine form the chloride ion? So let's the most important in case of the phosphorus also. So what are the oxidation state respectively in case of the phosphorus? F3, F5, that depends on the condition. Similarly, sulfur itself is the whatever the part of the 16 family, and sulfur also related with number of enzymatic concern. So different enzymes are related with the sulfur. One of the below is the selenium. So in case of the selenium, this is also the toxic. Here are we have to see the different toxicity of different elements. Regarding arsenic, one of the poison, whatever poisonous compounds and present and the so we have to see the P block elements are related with the directly approach to the different technologies. Why those particular technology? Because of their values in periodic table. Silicon, most important. Then halogens, oxygen family, where also the number of queries. Why H2 is water and why H2S is gas. So that's also related with the atomic properties and whatever the electron activity, electron affinity, their respective atomic size. So those are the concern of the question. And so here various P block elements produce a number of compounds, organic as well as the inorganic. So boron trichloride, one of the compound. BH3 boron hydride, that is B2 acid. So whatever we can get this particular here, something toxic materials are also antimony toxic. Whatever the tin toxic. Therefore, the selenium the toxic. So why these toxic and what are those adverse effects? So selenium and arsenic, one more, and that is the antimony or the tin, the tellurium. So these are the some of the they exhibits toxicity in uh, the different compounds. So now we have to continue for that. And here are the some questions. Describe the method of preparation of boric acid, borox, diborane, and boron trifluoride because these are the compounds. So how the boric acid, the borax, the diborane, that is the B2S6 and boron. So these are the compounds boron trifluoride. So most of their respective preparations. Then we have one of the most important, whatever I have mentioned, the diborane. So what is the structure of the diborane? We have whether there is any special compound, and in case of the boron trifluoride, all of you are well known that something electron deficient compound. In case of the boron trifluoride, their octet is not complete. So, in case of we have communicated the family B block, the boron one. So, boron, different compound, borax, boric acid, boron trifluoride. Double salts are also related with those. For example, in case of the potassium sulfate and aluminum sulfate, so potash alum, that is the double salt. So there are a number of examples of the double salts. Then the next one, the question appears, describe the preparation proper and usage of aluminium trichloride and potash alum. This one is the most important concern because uh, here aluminium, the, first of all aluminium trichloride and then potash alum. The potash alum itself is potassium sulfate dot the potassium sulfate and aluminum sulfate, potassium. Then we have their aluminum trichloride structure. This is also electron deficient because three of the chlorine electron from the three chlorine and aluminum, where the electronic configuration that indicates that here this aluminum 13 1s2 2s2 2p6. So that is the here the 13. So whatever that particular, and that is the aluminum. So aluminum trichloride, whatever we can say the boron here, the three electrons. So here ns2 1s2 2s2 2p6, and then 3s2 3p 3s2 3s2, and then 3p1. That is the electronic configuration of the in case of, so that we have the P1, the 3s2 P1 in case of the aluminum. So certainly we can say that is here the aluminum trichloride. Other maybe whatever the allotropes are also the characteristics of these P block elements. Allotropes and whatever the crystalline carbon, and even the diamond, the and the graphite. These are also responsible for the p block elements. So here the whatever we can say the sulfur also having the allotropes we have. So all those are the sulfur and carbon allotropes are there. Carbon case is the diamond, and the graphite and the black carbon. So here, similarly, in case of the sulfur, allotropes are monoclinic sulfur and whatever the others monorhombic sulfur. Rhombic and monoclinic, two different uh, allotropic form of the solid sulfur. So here another is the structure and property of carbon monoxide and carbon dioxide and silicon dioxide. So these are also because carbon and silicon are in the same group, and they exhibit specific characteristics. Carbon monoxide, very specific compound, and that is the poison. So in our body, the relationship of carbon monoxide is much more than the carbon dioxide. So why this carbon monoxide is poison? Carbon dioxide is also the toxic, but most toxic effect is of the carbon monoxide. Structure, whatever the structure will be carbon double, having the four electrons and from oxygen two. So therefore, the coordinate bond and double bond will be formed. So here we can say carbon monoxide. Then carbon dioxide differentiate to carbon double bond oxygen. Here a double bond, both side double bond oxygen. And silicon case, silicon is also be here because that is, however, that is also the family of the carbon. So here also silicon oxide is also silicon oxygen bonds. Now the next slide, and that next slide, whatever here also the another expert relationship between whatever the hydrolytic behavior of carbon, chloride and silica. This the carbon CCl4, SiCl4. That is the next one, carbide. This is also most whatever the average, whatever the hard silicon carbide, both combined, carbon and silicon. Why? Carbon and silicon both are the tetravalent because in the same group, so they combine with each other, and the silicon carbide hard material is obtained. As soon as the manufacture of ammonia and nitric acids are also the compounds of the P block elements. HNO3, nitric acid, then we have the ammonia gas, NH3. So, hello, we have know about the ammonia gas. This can be easily prepared by the air which is present. So here the nitrogen, because the nitrogen inert one, but that is taken from the air. The nitrogen, whatever the liquid nitrogen, further nitrogen. So that is also the concern of the pandemic concern, and where the the nitrogen containing compounds as well as. So relationship between the properties, uh, ammonia and nitric acid. Both are the different characteristics. Ammonia itself, the basic in nature, then nitric acid, the name itself, the acidic behavior. And further, we can say that the agriculture, where nitrogen fixation appears, and natural and industrial, the relationship. Then nitrogenous, phosphatic, and mixed fertilizers, whatever the urea. Then there are certain NPK, that is the mixed one. Nitrogen, the potassium, then the K. So these are the questions, and those can be explained here. Some application, the significance of the P block elements. Mostly in the fertilizers, chemical compound that directly supplying the elements of primary importance. That is the nitrogen, phosphorus, and potassium to soil are known as the fertilizers. So here the phosphorus, potassium also um, acts as a fertilizer, chemical compound directly supplying the element of primary importance. That is the nitrogen, most one. Nitrogen, 79% is the part of the air where the nitrogen is present. So, nitrogen in the form of the nitrogen gas. Whatever, if suppose we have the air composition where about 20% is the oxygen. If oxygen contents are increase in the air, so there will be no life because explosion occurs. So whatever the relationship of those phosphorus, potassium to, and here phosphorus and potassium to soil, and these are the fertilizers, chemical compound, active compound. So as a fertilizer may supply one or two or more than one of these elements, maybe nitrogen, potassium, and sulfur, and except the potassium itself is alkali metal, and the classification, the fertilizer. Nitrogen and phosphorus, that is also the part of the P block. Potassium fertilizer, this is related with the alkali metals. Now the mixing, whatever the NPK, nitrogen containing compound, or how this evolve. So here we have to see the different. Here are the some question. What is the state of hybridization in nitrogen? DS already discussed in case of the hybridization. So here state of hybridization in nitrogen is the sp3. Name three elements which are essential to plant growth. Nitrogen, phosphorus, and potassium are responsible, and these are the manures, and these can be responsible for the plant growth. The two compounds which are considered as nitrogenous fertilizers, the ammonium sulfate, whatever in case of the ammonium sulfate, some nitrogen containing compounds are also added, and urea. So the sulfur contains here because of the urea itself is also most relevant. carbon and nitrogen. H2C and H2. So now another question, amphoteric. This is also most important concern. Alkali acidic oxides, oxygen containing compound. That is also the great value of the oxygen. So very great elements are present in P block elements, and very enormous, whatever we can say, various significance of these P block element and their respective compounds. Amphoteric, whatever that particular, the answer itself is the tin oxide. Carbon dioxide, calcium oxide, then silicon oxide, and we have now graphite. This have the similarity with the boron nitride. So these are the questions. Now S bond is present in which of the ion pairs? Further, this is S2. So here the answer S4O2 2 minus S2. Here one more question correct, decreasing bond dissociation enthalpy. And the answer itself is the C, chlorine, bromine, fluorine, and whatever this one. This one. Now we can summarize what can another question which of the statement is correct. Genome, however, inert gases also inert gas compounds are also present, but is that speroplanar shape. In this case of carbon tetrachloride and water, which one is the polarity is also important. Here, that one more octet rule is not valid for this. That is the carbon monoxide. Oxygen follow the octet completion. Water H2O, oxygen octet complete. In case of the carbon, two oxygens are there, so this is validity of another one more thing is whatever this was repeated. And thanks. Any of the whatever we can summarize that P block elements have the great opportunity and values, and the most one silicon oxide, that is also the chips, the carbon compounds, especially of the hydrocarbon organic compounds. Hydrocarbon in case of the carbon family. So carbon, hydrocarbon, a number of compounds, and even the carbon containing compounds in our body, that is the life supporting chemicals, the carbohydrate, proteins, fats, the deoxyribonucleic acid and ribonucleic acid. All those are the carbon containing whatever the these things, and we can say the various specific electronic configuration, even some toxic compounds are also formed. Carbon monoxide, then we have the selenium, then we have the arsenic. Arsenic and selenium are poison. In case of the selenium compound, that can also destroy the skin part of then. So a number of elements and very specific characteristics and very specific applications are there. So we can say periodic table, the block of P itself is one of the important, where the last one is the inert gas and inert gases uh, group. So lastly, the boron family, one thing, P1. The carbon family, that is whatever P2. And nitrogen family, that we have the P3. So P3 oxygen, alkanides having the 4. So oxygen itself is the P4. So what? How many electrons are there in outer shell oxygen? That is the S 2 electron, and then the P the same word, oxygen electronic competition. So oxygen is also one of the great value concern. Then the sulfur. So you can say inert gases, and then the we have to see inert gases, the last one, and here this we have the boron family. Boron compounds are also important, relevant with the electron deficient compounds are formed in case of the boron family. Boron, diboron, whatever there may be, specific borans are also present. So lastly, I can say that group 13, 14, 15, 16, 17, and 18 are of the part of the P block elements, and thus are the most relevant concern. So that is all about any of the query. Then you can ask me whatever. Thank you for patience listening, and I think that the important relations will be appreciated. Whatever anyone can ask me the question, whatever I have presented the um, email ID, and can ask me the question. So all of the best. I think you can get more and more relevant informations regarding the P block elements, the great values of a P block element. Okay, all the best.